Dr. Proctor, and I'm a little kid who wants to learn about science! Wow, that's a cool hat. Thick! Can I make fun of your male pattern baldness? No! Okay. What's with your arms anyway? Sun's out, guns out, kid. I'm here to talk about meiosis and mitosis. Wow! That's really interesting! Pay attention! Anyway, I'm here to teach about meiosis and mitosis. But how does mitosis and meiosis work? Well, I'll show you! And all of you wonderful viewers. I am Dr. Proctor. And I'm a little boy who wants to learn about science. That's great! Because guess what? I happen to teach science. I'm a sock professor. That's incredible. I know, right? What do you want to learn about today, little kid? Well, I want to learn about meiosis and mitosis. Great! Because I happen to specialize in that! And screaming! And screaming! And science. That's cool. It's very cool. It's the coolest thing you've ever seen. Alright, so here's how the mitosis works in form of super cool visual display.
The first stage of mitosis is prophase. In this phase, the nuclear envelope breaks down and it releases the chromosomes so that they can be included in mitosis. Also in this stage, the spindle fibers and the centromeres begin to line up in their parts of the cell. The next stage of mitosis is metaphase. In this stage, chromosomes line up in the middle of the cell, and the centromeres line on the opposing sides of the cell. Also during this stage, the spindle fibers have finished taking their places and are ready to move the chromosomes. The third stage of mitosis is anaphase. In this phase, the chromosomes are separated and pulled apart by the spindle fibers to the opposite sides. When this phase is finished, both sides of the cell have a full set of chromosomes. The fourth stage of mitosis is telophase. In telophase, chromosomes gravitate together and the nuclear envelope begins to reform around them. The spindle fibers begin to dissolve as they are no longer needed. And the last stage of mitosis is cytokinesis. During this stage, the cytoplasm is divided. There are now two identical, this is also known as diploid, cells, and they are fully functional.
Wow! That sure was an interesting visual display of what mitosis in a sock cell looks like. That's what I was gonna say, but you had to go and steal my thunder. Yeah! That was great! But wait! That was mitosis! It sure was! I thought you said there were two things, division type stuff. There are. I was just getting to meiosis! The other one I was gonna talk about until you ruined it. Anyway, meiosis looks a little something like this. Woo!
Meiosis. Prophase is the first stage of meiosis. In prophase 1, the nuclear envelope breaks down, releasing chromosomes. Spindle fibers and centromeres form and begin to line up. This is where crossovers occur. The next phase is metaphase 1. In metaphase 1, chromosomes line up along middle of a cell. Centromeres align on the sides of the cell. The spindle fibers take their places. This is also where independent assortment takes place. The next phase is called anaphase 1. Chromosomes are pulled apart by spindle fibers. At this point, both sides have a full chromosome set. The next phase is called telophase 1. Chromosomes collect, a nuclear envelope reforms. The next phase is called cytokinesis. Cytoplasm divides, there are now 2 diploid cells. There is now prophase 2. Spindle fibers reform, centromeres again move towards opposite cell sides. Nuclear envelope breaks down again. Spindle fibers and centromeres finish lining up again. Chromosomes again line up in the middle of the cell. The next phase of meiosis is called metaphase 2. Spindle fibers and centromeres finish lining up again. Chromosomes align up again in the middle of the cell. Anaphase 2 is the next phase. Chromosomes are pulled apart by the spindle fibers into their chromatids so that each side of the 2 cells has 1/2 the DNA makeup of the parent. The next phase is called telophase 2. The nuclear envelope reforms in each of the cells. Spindle fibers begin to dissolve. The final stage is called cytokinesis 2. Cytoplasm divides again. There are now 4 cells, and each of them has 1/2 the DNA of the original cell. These are known as gametes.
Wow, that was so interesting. I know, right? Now you know what meiosis and mitosis look like. But I wasn't really paying attention. What? In the sense that I don't quite know how they're different. You think that makes it better? Anyway, because some people weren't paying attention, you silly sock, I am going to explain the differences between meiosis and mitosis. Yes. What's wrong with your arms? Sun's out, guns out, kid. Yeah. Ooh, yeah. I'm frightened. God!
There are several differences between mitosis and meiosis. The main one is that in mitosis there is only one of each stage. During meiosis, there are 2 of each stage. There are, as well as the first 4 stages of prophase, metaphase, anaphase, and telophase. There is also prophase 2, metaphase 2, anaphase 2, and telophase 2. The second major difference is that while mitosis, full sets of chromosomes, produces 2 identical cells known as diploid cells that have exactly the same as the parent. Meiosis produces haploid cells. These each have 1/2 the DNA of the parent cell.
Well, that's all the time we have today, folks. Hope you learned a lot about mitosis and meiosis. I sure did, Dr. Sock. I think that's your name? Yeah, probably. Well, that's how education works. Things are taught and things are learned. Learned. Whatever. I'm gonna go back to doing whatever I do. You go back to whatever you do. Listening to J-pop and chewing bubblegum, sir. Dang, this kid knows how to live. High five!